So hello, everyone, and welcome to lecture number 12. This is the 6th week. We're finishing the 6th week. Oh my God, almost halfway done with the semester already. I know, I'm crying inside. I'm sure it must be the same for all of you guys. We are on chapter 11. And last time we spoke about finding the median, the 25th percentile, the 75th percentile. We didn't actually talk about how to find it. We just talk about the concept of the median, which is the halfway point in terms of your data, 50% below, 50% above, and the 25th percentile, 25% below, the rest above, the 75th percentile, 75% below, the rest above. And the question is, can we do beyond that? Can we talk about any position in your data and talk about the percent that's below it? And you're probably familiar with this from just life, but something like, oh yeah, you scored in the 90th percentile on this standardized exam, or your child is in the 78th percentile in height or weight for their age group, etc. This idea of percentiles pops up a lot in, real life. So let's talk now about the concept of a percentile. So a score is at the kth percentile if k percents of all scores are less than or equal to that score. So you are at the 90th percentile if 90% of your data is less than or equal to you. And you're at the 70th percentile if 70%, oh, we did, Maria, we talked about this, I remember this one, but never a bad idea to recap anyway. So 70% of your data is less than or equal to you, you're at the 70th percentile. So this one right here, oh, and we did this example too. I remember this now, it's all coming back to me. So this is an example of a cumulative frequency plot, also called an ogive, O-G-I-V-E, although that term is not used at all in this course. But what it is it allows you to kind of get a snapshot of the accumulation of frequencies from the first number to the last. Of course, by the end, we're of course going to be at 100%. We've gotten everything by that point. And we start at 0%, we have nothing. And then as you accumulate data, it's going to go up and up and up. And we can use that to kind of get an idea of, for example, the 40th percentile. If I want the 40th percentile, all I need to do is go here to 40 and go over to the graph and then go down from the graph. And it looks like the 40th percentile would be roughly, 20 cents or so, whatever number this is. There is some approximation because we don't have every possible number labeled. And of course, we are interpolating. We have this data point right here. We have this data point right here, but we don't technically have any data in between. So we just connect it with a straight line and then guess. But is it accurate? Well, it's probably fairly close, but it might not be exactly 100% accurate. And similar with the 50th percentile, go over to the 50th percent mark. And that's, of course, that's the median, 50%. And again, it's estimates because no graph is perfect. And even if it was perfect, our interpretation of it, we have to do a little guesswork. Oh, it's about 25 or 24 and so on, without knowing the actual data. So we did that last time, and hopefully that rings a bell. So some data have special names. The 50th percentile, the one right in the middle, we have another name for that one, and it is called the median. The median, or the second quartile, because it divides it into two quarters, 25%, another 25% is 50%. Or Q2. All these are the same. The median, the second quartile, Q2, and the 50th percentile. So that's 4 ways of saying the same thing. And that is the point right in the middle. Half the data is less, half the data is more. You're right in the middle. So how do you find the median? The easiest way is as follows. And this box kind of says what I'm about to say, but I'm going to do it slightly differently. The way that you find the median is as follows. You count the number of data points. In this example here, how many data points are there?
7.
1, 2, 3, 4, 5, 6, 7. There's 7 data points. You add 1 to that. So if you add 1 to 7, what do you get?
8.
8. And then you divide by 2. Number of data points plus 1. And then you divide that by 2. What do you get when we do that? What
the median?
Well, say what number do we get in this example?
4.
4. That means that the median is not the number 4, although coincidentally it might be. What it means is the median is the 4th data point. Now, when I look at this data, what is the 4th data point? Spoiler alert, it's not 1. Even though 1 is the 4th one listed.
Oh, you
Would it
don't
be
count it?
7?
So what do I do first?
Order them.
I have to put them in order. So 1 took care of that one. 4 took care of that one. 6, 7, 8, 10, 12. So the first thing we do is we put them in order. Then the median is the 4th data point. So the median is Q2. The median Q2 is equal to 7. It is the 4th data point. Now, once I find the median, how do I go about? And I find the 25th percentile. So what we do here is we ignore the median, which was 7, and we look at all the data points to the left of 7, which in our case is 146. How many data points is that? 146?
3.
3. Add 1. What do we get?
4.
Divide by 2.
2.
That means the 2nd data point is going to be our Q1. In this case, Q1, the 25th percentile is equal to 4. I will do the same thing for the other side. The 2nd data point will be my Q3. So what is Q3 equal to?
10.
10. We'll do a few more examples of this, but order them. And then number of data points plus 1 divided by 2, that's the median. Once you have that, you look to the left, use exactly the same formula to find the median of that. You look to the right, exactly the same formula to find the median of that. So let's go ahead now and do the second one here on the list. Second example. How many data points do we, well, first let's order them. What goes first?
1.
1, then?
4.
Then?
5.
Then?
6.
6.
7.
7.
8.
8.
10.
10.
12. 14.
12. 14. Let's just confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, wonderful. So the first thing we do is we order them. So there's 9. So now we find the median. We take the number of data points, we add 1, and then we divide by 2. So if you take 9 and you add 1 and you divide by 2, what do you get?
So you
5.
take 9. Yeah, 5.
Sorry, what?
So you take 9 plus 1, you get 10. Over 2, you get 5.
Exactly, you get 5. So does that mean that the Q2 is equal to 5? Does that mean
No,
the
it's the 5th number.
5th number? So Q2 is equal to 7. Someone chatted what they say. They said, I said, no. Okay. So Q2 is equal to 7. So now we want to find Q1. So to do Q1, we look to the left of the median. We look to the left of 7. How many data points are there?
4.
4. Add 1 and divide by 2. What do we get?
2.5.
2.5. So the Q1 is the 2.5 data point. So what does that mean, the 2.5 data point? We have the second data point, it's 4, and the third data point is 5. So what is a 2.5 data point? How do we find Q1 in this example? Who can venture a guess how to find say again?
And then divide that by 2.
What's divided by 2? So someone said in the chat whether it was correct, but what do you say?
I suggested adding 4 plus 5 and then dividing it by 2.
Yeah, we take the average of those two. So Q1 is actually equal to 4.5. It's not 4, it's not 5, it's the average of them. And similarly, what is Q3 equal to? What is Q3 equal to?
11.
11. Because we again have 4 data points. 4 plus 1 is 5, 2.5. That's halfway between 10 and 12. So we have that Q1 is 4.5 and Q3 is 11. Notice, by the way, that Q1 and Q3 are not actual data points. That's totally fine. All right, so go ahead then, and let's do the next one. So let's first order them. What do I get when I order them? Feel free to, speak up.
1,
1,
3,
3,
4,
4,
8,
8,
15, and 15.
15, and 15. How many data points is that?
6.
6,
6. So we add 1, divide by 2. What do we get?
3.
I don't think we got 3.
No,
3.5.
3.5. Which means what is the median? What is Q2 for this example?
Six.
Yes, it is the halfway between 4 and 8. Q2 is equal to 6. It is the average of the third number and the fourth number. It goes right here in the middle. Now, what is Q1?
Two.
Q1 is not 2. Why do you say it was 2? Let's understand. Where do you get 2 from?
Well, I did the same thing I did to get Q2. So for Q2, I did 4 plus 8 divided by 2, and I got 6.
Right.
And so for Q1, I did 3 plus 1 divided by 2.
But wait a second. Why are you only using 3 and 1? How many data points are there to the left of Q2?
Do we count 4 as well?
Is 4 to the left of Q2?
Oh, that's right. That's right. So it would be 4.
So it's still not 4 though. How many data points are
3.
to? How many data?
It'll be
Yes.
3.
How many data points are to the left of Q2?
3.
3. So you 3 plus 1.
It's 4 plus 4, you get 8 divided by 2, you get 4. Right?
Oh, hold on. The number of data points is 3 data points to the left, correct?
Correct.
So add 1 to that.
Oh, okay.
Add 1 to that. What do you get?
4.
You divide it by 2.
Oh, okay, I'm doing it wrong.
But my question, divided by 2, what do we get?
2.
So that means that Q1 is the second data point. What is the second data point?
3.
3, straight up, not an average. When there's an odd number, it's going to be right there. And what is Q3? What is Q3?
The
15.
15 before the last 15.
Yes, Q3 is 15. If it matters which 15, it's the first one, but Q3 as a number is 15. So I want you to go ahead while I look for my water bottle. I want you to go ahead and can you guys see the last one on the page? Or should I scroll up a little bit? Go ahead and I'll be right back. I'm going to pause it while I go. And go ahead, please do that. I will be right back. Are you coming to screen still? Okay. Okay, well, it wasn't there. And resume share. Okay, so what's the first thing we do here?
Order the numbers.
Order the numbers, and when we do, what do we get?
1, 2, 3, 4, 8, 10, 12, 15.
Let's confirm. We started with 4, 5, 6, 7, 8, and we have 8 at the end, so it's probably correct. Okay, what's the next thing we do? Now that we've ordered them, what's the next thing we do?
Find Q2.
Find Q2. How do I find Q2?
Do the n plus 1 over 2 formula.
Okay, so what's n?
8,
8 plus 1 is
9,
over 2,
4.5,
4.5. So where am I going to find the median?
between 8 and 10.
Look again. While you're thinking about that, Genesis, what's your question?
Professor, to find like the Q1, I kind of do it differently. For example, like for the Q1, I added 2 plus 3, which gave me 5. And then the 2 digits that I'm using are 2. So I divided by 2, which gave me 2.5.
Okay, but how do you know that it's between these two numbers?
I don't know. I kind of use my finger for that.
But you gotta first find Q2. You have to first find Q2 before you can find Q1. Because let's look what happens here. Okay, and I'm not saying you're wrong about what you said necessarily, but let's look what happens. What is Q2 in this example? It's the 4.5th data point, right? It's 8 plus 1, which is 9 over 2 equals 4.5, right? Yes?
Yeah.
Okay, so Elizabeth was correct. You put it in the chat. It's halfway between the 4th and the 5th. So Q2 is equal to 6. Now, once I've determined Q2, I look to the left of Q2. Now, you said it's halfway between 2 and 3, which is correct. And you eyeballed that, which is fine because it's a small number. It's not hard to see. My formula is more rigorous in the cases where it might be harder to see. What is my formula? There's 4 data points. 4 plus 1 is 5. Divide that by 2, 2.5. It's halfway between the second and the third. And coincidentally, happens to actually have the value 2.5, which is certainly not normal. And when I look to the right of Q2, I'm also going to have 4 data points. So what is Q3 going to be? In this example, what is Q3?
13.
Well, it's halfway between which two data points?
Oh, it's 11.
It's 11. And I hear a few people in the chat, so they probably say, yeah, Q3 is 11. Does that make sense? Hopefully it does. We did some 4 examples, so hopefully that makes sense. We're not going to do this activity because we're not actually here, so we're going to skip that. Okay, next, the 5-number summary and box plots. So the 5-number summary are 5 numbers that we compute that help us describe the data. 3 of them we just found, Q1, the median, and Q3. And even though it wasn't really hard to find Q1, Q2, and Q3, it's a lot easier to find the last 2 numbers, which are the minimum and the maximum. How do I find the minimum of my data set or the maximum of my data set? Not a trick question, just a really easy question. How do I find the minimum and maximum of my data set?
The smallest and the largest number.
Smallest and the largest numbers. So when you line them up from smallest to largest, the minimum is the first one, the maximum is the last one. Very straightforward. Probably the easiest thing we're going to do all year. And then what we do is we display the 5-number summary in something called a box plot. And a box plot, as shown here in the picture, very, very straightforward. I mean, hard to describe in words, but easy to see. You have the minimum and then a line to Q1 and then a line at the median and then a line at Q3 and then a line to the end to the maximum, and you make a little box here, and that's your box plot. So it used to be called a box and whisker plot because it looks like kind of like the whiskers of a cat if you were really, really, really stretched. Yeah, it's a big stretch, but that's what it used to be called. Okay, so in our example, the minimum is about 38. Q1 is about 63. The median is about 74. Q3 is about 83. And the maximum is a little under 100. Does that make sense?
Yes.
So let's look at this box plot beneath it. Based upon this box plot, what is your 5-number summary? What's the minimum based upon this box plot?
50.
Minimum is 50. What's Q1?
80.
80. What's Q2?
90.
What's Q3?
100.
And what is the maximum?
110.
Very straightforward, correct? I think it's a lot easier to interpret a box plot than it is to make one yourself. But in order to make the box plot, you actually have to go ahead and compute the 5-number summary. That means you line them up. There's the min, there's the max. That's easy. And then you do what you just did a few minutes ago. You find Q2 and then Q1 and then Q3, and you have your 5-number summary. And we're going to skip this one because we're not all together. Okay, so example. 2 psychologists randomly divided 139 students into 3 groups. Group 1 learned the names of the others using the name game, where the first student states their full name. The second student states their full name and that of the first student, and so on. I would really hope to go first in that example. Group 2 learned the name using the name game with the addition that each student stated their favorite activity. Mine would not be playing the name game. In group 3, each student learned the names by going around and introducing him or herself to each of the other students. 1 year later, the students were sent photos of the others in the group and asked to give the names of as many other students as he or she could remember. The variable recorded was the percentage of names that he or she recalled, and here are the results. So take a second and look at those results. By the way, you'll notice something in those box plots that we haven't spoken about. What do you see in those box plots that you might be a little confused about, justifiably so?
The dots that are off to the right.
The dots that are off to the right. What do you think those dots represent?
Outliers.
Outliers, exactly. So yes, outliers. So when you have outliers, when you make your 5-number summary and you go to your maximum is not really the true max. It's the maximum except for the outliers. So when I make my whisker, I don't go automatically to the maximum and the minimum, but if there are outliers, I don't include them. I make little dots for them because they're there, they're part of my data. Excuse me, but I don't go all the way to the end. I go to the last non-outlier. That's how far my whiskers go. So which method of these three would you think is the most effective for group 1, for group 2, or for group 3? Based upon those box plots, which method would you say is the most effective? Are we all looking at the same thing, or we're just not sure what the answer is?
Just not sure.
I'm
Okay.
stuck between group 1 and 2 because 2 has the longer whisker that's going farther, but 1 has the higher median.
So what would you say is a better measure of the typical person?
That would be the median. Though.
You would think
Yeah.
it's the median, right? It's the median is a measure of center, correct? Right, so which median is the highest?
Group 1.
Group 1. So it would certainly seem as if group 1, as a general rule, is the most effective, even though for group 2, you have a higher maximum. Well, except for that big outlier in group 1. What do you think that outlier is in group 1, by the way? If you had to describe the person who's that outlier, how would you describe them? Anyone? Bueller? Someone in chat said, someone who did not participate. How would someone who did not participate manage to remember 100% of people's names?
Yeah, it's somebody with like photographic memory.
That's what I would think. Exactly. Someone with like a photographic memory who just, I actually knew a guy like that back when I was in high school. I went to a boarding school, religious boarding school, and every year, it was for high school, 9th through 12th. And every year, 8th graders from various cities would come on a weekend to kind of scope the place out. And the guy who ran that group year in and year out, he just never forgot a name. Years later, he would see me and he would remember everyone knew that this guy, how does he do it? Well, we don't know how he did it. Was it a photographic memory? Did he have a technique of associating a name? I don't know. To this day, this has been 30 years. You probably still remember who I am now. I look exactly the same as I did, when I was 13. But so besides that guy with the photographic memory, it looks like group 1 is, as a general rule, the most effective. It has the highest median. Which group had the most variability, had the most spread in values, other than outliers?
That would be group 2.
And that would be group 2. So group 2 had 25% of the people here, 25% here, 25% here, and a full 25% of the people in group 2 remembered fewer than what, 5%? 5%, right? that's 1 and 4 remembered very little. Whereas for the first group, 1 and 4 was somewhere between 0 and 20. So I think the median is most likely the best measure of effectiveness in this case. Does that make sense? Everyone with me?
Yeah. How do they measure the outliers, or how do they decide that those are dots?
So that's a great question. And they don't have it here, but it's a wonderful question. Let's see if they do it coming up. They don't. So let me give that to you just because you asked. And it's not hard to compute. It's just they didn't do it. But what they do is as follows. How do they determine whether or not something's an outlier? Here is the general idea. You could first compute, let's go somewhere where I have more room to write. You first compute, step 1, you compute what's called the IQR. Anyone know what IQR stands for in this context? You might have learned statistics at some point. Anyone know what the IQR is? The IQR is called the interquartile range, and it is a distance from Q1 to Q3. It's Q3 minus Q1 because we want a positive number. So step 1, we compute the IQR, which is not hard because if you're going to make your 5-number summary, then we have Q3 and we have Q1. So in this example here, this first one, what is Q3? What's Q3 for the first example?
40.
It looks like it's a little bit above 40, but 41, 42, something like that. And what's Q1?
Like 19.
Like 19. So what would the IQR be in our example here? Approximately, at least?
40 minus 19.
Which is?
Or-
I didn't hear. Did you say the answer? I didn't hear that.
21.
You broke up, but I think you said something about 23, give or take?
21.
24? Okay, 24. So
21.
21. Okay, 21. All right, so the IQR is 21. Step 2. Take the IQR and multiply it by 1.5, by 1.5. What is 1.5? In our case, what is 1.5 times the IQR?
$31.5.
31.5. All right. 31.5. Step 3. Take the Q1 and subtract that number. In our case, 31.5. But in general, take the Q1 and subtract this number. What was Q1 again?
We said 19.
19. So take 19 and subtract 31.5. What do you get? What do you get?
12.5.
Negative 12.5. Right?
Yes.
Now, go to Q3 and add this, and add the same number. Go to Q3 and add the same number. What do you get when we do Q3 plus that number?
$52.5.
53.5, give or take. These two numbers, anything past them is considered an outlier. past these are the outliers. So is this data here past 53.5?
Yep.
So we got an outlier. It can't be 53.5. I'm not sure who said that. That doesn't make any sense.
Yeah, I was looking at the box plot.
Yeah, Q3 is 42 or 41, and 41 plus 31.5 is what, 70, 72.5. Now, it's still an outlier. Anything past 72.5 on the right or negative 12.5 on the left would be an outlier. Does that make sense?
Yep. And we're not gonna have to do this for any quiz, right? This is just
No,
general.
no, you asked, so I answered.
Okay, perfect.
But it's unless we come across it, we're not gonna worry about it.
Got it.
Okay. Let's not worry about this. And you'll notice here, by the way, this is just a sixth grade, like a science project or something. Or yeah, American Statistical Association poster competition for grades 4 to 6. You see a dot plot, you see a bar graph, and you see box and whisker plots. So these are certainly in the curriculum for kids and are not really that difficult to learn. So yeah, so you should know them and stuff. Here's one last example. 3rd and 6th grade hours of sleep. Holy crap, there's a 12 in there. Hate that person. Okay, so consider the box and whisker plots. For the 3rd graders, the median is 10. Q3 is also 10. Q1 is 9, minimum is 7, maximum is 12. Someone chatted something. Yeah, must be nice, exactly. In 6th grade, minimum is 5. Oh, come on, kids, too early for that. 5, Q1 equals 8, median 8.5, Q3 9.5, maximum 11. So consider the 2 box and whisker plots. The 2 have about a 1 to 1.5 hour difference. That's the majority, the middle 50%, 9 to 10, 8 to 9.5, 1.5 hours. They also show that most 3rd graders have a 9 to 10 hours of sleep, while the 6th graders, it says get 7 to 8 hours, but I don't see it that way. I still see 8 to 9.5 hours. But either way, if you were her teacher, how would you help improve this student's box and whisker plots? What would you do?
In the first one, the medium and the Q3 are the same.
That can happen. I mean, if you have lots of your data as tens, I mean, look at this data here. If I give you the following data, like 1, 2, 2, 2, 2, and 7, for example, or let's give one more, an 8, odd number. Then this here is your median, right? It's the middle one. The middle of the left, the middle of the right, you see that Q1 and Q2 are both 2, right? Correct, yes?
Yeah.
It can happen. It can happen. Trying to think how. Well, what's the IQR in this first case?
The minimum is 7.
No, IQR doesn't care about minimum.
1.
IQR is Q3 minus Q1. It's 1.
1.
right? Now multiply 1 by 1.5, what do you get?
1.5.
1.5. If I add 1.5 from 10, I get 11.5. We certainly have an outlier here. And if I subtract 1.5 from 9, we get 7.5. We have an outlier here. But then again, outliers weren't really in the curriculum for this particular section. So
I was thinking maybe we could have the graphs overlap, have them purple where they are, so it's easy to compare the two, and maybe adding half points on the bar at the bottom. The time.
okay, so adding decimals. I'm not sure overlapping would be good though, because don't you think that would confuse things if they were overlapped?
Overlapping.
I don't know.
Yeah.
I'm just trying to figure out if I was a teacher how this could be easy.
Yeah, exactly. For me, the first thing I asked myself is, okay, is the scale the same? And yeah, 7, 12, 5, 11. I mean, all the numbers are in the right spot. I don't know what I would do here. I don't really see any problem.
Is it based on outliers, how you were saying?
I mean, maybe, but we didn't technically cover that. I only did it because he asked. So yes and no.
Mhm.
How would you help her improve this? I don't know how I would help her improve this. I'm at a loss.
Maybe the bottom one, the 5, but that would also be an outlier. So
Yeah, I mean, outliers
Maybe.
again, outliers are outliers.
the only thing I can think of is just putting like little bars between 8 and 9, so we can see the decimal place there.
Oh, so you mean like on the axis themselves?
Yeah,
Yeah, I mean, you can always do that. But I was looking for something more substantial. And I really don't see anything. So if I were her teacher, I would say, good job. Now go leave me alone. Or something like that. I don't know.
Go enjoy your 8 hours of sleep.
Go enjoy your 8 hours of sleep. Exactly. You little asshole. Okay, moving on. So group activity. We don't have people here for groups, so we're probably gonna skip this one too. Yeah, we'll skip that one. Oh, this one. I remember this. I remember this. Okay, we can do this one. So the box plots on the next page show how efficient box plots can be in displaying a lot of information. Okay, the researcher who made them explains, a few years ago, I downloaded speed dating data from experiments conducted by Raymond Fishman, which represents about 8,000 dates by 551 people. On each date, people scored each other on attractiveness, intelligence, ambition, and some other things, along with a yes or no to sing the other person again on a regular date. For example, the rightmost box instead of box plots on attractiveness, right here, says, represents all of the people who got a median rating of 9 on attractiveness from the other people. So this one here, attractiveness, this is the box plot of those who received a 9 from other people. Okay, and on the vertical scale is whether or not they received a yes rating from others. Does it seem reasonable that people who were generally more attractive had a higher percentage of yes rates from other people? Does that seem like it's that it makes sense?
Yeah.
yeah.
Yeah, except for this outlier down here. This person had a median rating of 9. That means half the people gave that person a 9 or more, and yet only 20% of people would say they would vote, they would go out with that person. So what do you think might be a cause for this?
I heard him speak.
Or her? Why are they going in this direction only? Yeah, maybe the person was just really came across as being just extremely just rude or insensitive or misogynist or just who knows? There's always going to be outliers, but in general, it certainly seems that the more attractive the person, the more people are going to say, yeah, let's go out again. What do you notice about, for example, intelligence as being a factor affecting whether or not people are going to go out with them again?
It also increases, but there's kind of a dip on the last one, similar to the attractive one.
Yeah, well, this one, it seems like if someone's really, really intelligent, it actually it almost hurts them compared to being pretty intelligent. Like it's going up, but then it goes down again if they're too smart.
Feels like that's a metric and normal kind of scale that we saw in the other.
Yeah, yeah. that
It
was
goes
more-
up and down, like the scales that we saw before in the other one.
Yeah, I get that 100%. I also noticed just attractiveness. It really shoots up. The more attractive they are, the more yes ratings they're going to get. Whereas intelligence, it goes up, but you'll notice it doesn't really go up that much compared to this.
No.
And fun also. The more fun they seem to have, it shoots up pretty quickly.
Mhm.
Ambition shoots up and then kind of stabilizes. Once they're ambitious enough, it seems like it doesn't play a role. Sincerity goes up and again kind of stabilizes at some point. So there's a lot of information here that can be shown in these 5. In general, were people who were rated higher on these categories more desirable as a date than those who rated lower? Were 9s and 8s more desirable than 1s and 2s pretty much across the board?
Yep.
Yes. Is there a category that contains an exception to your answer in part A?
Maybe intelligence. I mean, if somebody was rated
Yeah.
a 10, maybe we could see it going down a little farther.
Yeah, maybe intelligence. Like even here, it doesn't go up nearly as much as the others do. It's pretty, I mean, yes, this is below 20%. This is 40 something percent, but it's never really shooting up significantly. What seems to be the worst category or categories in which to have a low rating?
Attractiveness
Yeah, can't beat that one.
and fun.
And fun. Attractiveness and fun seem to be the 2 big things. List 3 things that you find interesting about these data. Well, let's see. I'm low on this one, but I'm high on this one. I get it now. That all makes sense. What are 3 things that you see? Anyone see anything that is interesting about the data?
I think it's interesting that ambition stabilizes. That it only gets to a certain point.
Yeah, it's interesting, right? Once you reach a certain point, it's like, okay, that's good enough. I would have thought intelligence would have mattered more, but sucks to be me. What can you do? Okay, either way. And this takes us to the end of chapter 11. Yummy. So are there any questions on anything from chapter 11 that we did? Except for this one, which is just stupid. Let's just ignore that one. But the rest of it, are there any questions on anything from chapter 11? All right, good talk. You guys are a wonderful audience. Okay, let's see what we get next. Chapter 12. Oh, good. Finally, we get a good mathy chapter. You guys have probably been missing a good mathy chapter, haven't you?
Chapter 11 was pretty good. It was mathy, like you kind of
I
said.
don't know. I mean, it had numbers in it, but like arranging numbers and then picking which one is the one in the middle. I mean, that's not really that mathy.
It kind of took us back kind of to like what we did in elementary when we had to do that.
Well,
That's why.
that makes sense because this whole
Yeah.
course is designed to be able to teach what you're going to do in elementary school.
Hmm.
Who here is hopeful one day to be an elementary school teacher?
Me, I am.
Okay.
One,
Yeah.
2, 3.
Me.
I mean, are you all here specifically for elementary school, or it's just any teaching at all? Me, Sabina says, me.
And for me, it's specifically elementary and adolescence will be like middle school.
Okay. So I just, they hire me to teach this class, but is this specially designed for more elementary than, let's say, high school or
Yeah.
middle school?
Yeah, I
Yes,
think
I think so.
Elementary, middle school. 'Cause
Okay, all right. Well, that's good because that age group needs a strong math background for them to be able to do well later when it comes to high school math. So I'm imploring all of you, whether you like math or not, to make sure that you don't avoid it as much as possible when you're teaching, because in the long run, it's going to be worse for the students. So the more math we can do, the better, right? So we can prepare you to create stellar math geniuses for the next generation or something like that. I don't know. I don't even know what I'm saying right now. Okay, so let's go ahead and start because we're here, chapter 12. On the mean. Oh, wait. So last chapter, we did a kind of an average called the median. And the median is a very important average. It's used in many situations, but it's not really the one that is used more often out there in the world. The one that is used more often is the mean. In fact, if you take 10 tests in third grade or fourth grade, I remember this as a kid, trying to compute my average. I took all these tests. What's my average? Well, how do you do that? How do you get your average when you took all those tests as a kid?
You add all the tests and then divide by the number of tests.
Yeah, that's how you do an average, right? That's how we always do an average. So that's what the mean is. To compute the mean, X bar, add up, and that's the Greek symbol sigma. Add up all the values X in the data set and divide by the number of values N. So X bar is equal to the summation, to the sum of all of your X's divided by N, the number in your data set. That is the definition of X bar, the mean. Technically, it's called the arithmetic mean versus something else called the geometric mean, which we're not going to worry about, but I would be remiss if I didn't mention that there are other means that exist out there. Also, to example, to compare their weekly allowances. Some children made this chart using the applet at this website. It said, you have Ari, Beth, Cheng, Doug, and Irvin. And for example, what was Ari's allowance according to this bar graph?
$5.
Assuming it's dollars, we'll assume.
Yeah, I think there's a dollars under allowance.
Yes, I see it now. Yes, $5. And Beth is so lucky she gets $10. And then there's Chang and Doug and Irvin. So first, is this a histogram?
Yes.
It is not a histogram. It looks like a histogram, but it's not a histogram. It is not a histogram. It is a bar graph. What's the difference between a histogram and a bar graph? Remember, a bar graph is for categorical data. Ari, Beth, Chang, Doug, and Irvin are not numbers. They are categories, small categories. You know, the category of Ari and Beth and Chang and Doug and Irvin. If it was a histogram, remember the histogram is only for quantitative data. And the vertical axis is frequency, how often it occurs. And the horizontal data are these groups, 0 to 10, 10 to 20, 20 to 30, and so on. So if I were to make a histogram of this data, the histogram would look something like, I can say 0 to 1 and 1 to 2. Oh, those are pretty small widths. But in the interest of hurrying up, I can say 0 to 3, 3 to 6, 6 to 9, and 9 to 12. So how many of my data set is between 0 and 3?
0,
0. How many is between 3 and 6?
2.
It depends if we're going left or right, but I think in this course, we always go to the right. So yeah, 2. And that will be this one, which is between 3 and 6, and this one, which is between 3 and 6. And then between 6 and 9, how many are there?
2.
2 again. And then between 9 and 12, how many are there?
There's 1.
So this would be a histogram of the data versus a bar graph, which just gives the actual values for each category. You see the difference between them?
Yeah, the histogram is also the one that there's no space between them, right?
Yes, exactly.
Oh,
Histograms are clumped up because the classes are right next to each other.
okay, perfect.
Exactly. Okay. Now, if the formula for the mean was X bar is equal to the sum of my data points divided by n, then I can rearrange this formula and get the sum of my data points is equal to n times the average. Does that make sense? Do you agree? You just cross multiply this times this equals this, correct? Yes?
Yep.
Yeah.
Okay. And sometimes it's useful to actually use this formula versus this formula. This formula finds the mean, and this formula uses the mean to find the total. It's the same formula rearranged, but the purpose of the formula is different in the first case versus the second case. So suppose that you want to estimate the total value of the change carried by students in your class. You want the total, you want the sum. Well, if I know how many students I have, n, and I know the average amount carried by everyone, I can just take this total, multiply it by the average, and that will give me the sum. Unfortunately, I don't know everyone's amounts, but if I can somehow estimate it or guess it, or maybe take a sample of a few of you and see and use that as my guesstimate, then I can make a pretty good approximation of the total. Does that seem reasonable?
Yeah.
Okay, so, and this actually is extremely useful out there in the world. If I want to know the net wealth of a city, for example, of Los Angeles, how much wealth is in Los Angeles? Okay, I can't, I mean, I could, but who's going to tell me? I can't necessarily go out and look up every single person's wealth and add it all together. But if I can somehow find a sample of, let's say, 1,000 people who are willing to share this information, and I can take the sample and compute the average of that sample, I can multiply that average by the total amount to get a pretty good approximation of the total amount of wealth in the city, even if it's not 100% accurate. Make sense? Agreed?
Yes.
Yeah.
Okay, do I want to keep going today? I think we've done enough and you have a test coming up, right? And so let's stop here for today. And we'll stop after page 3. And again, the test will be posted, should be posted today within a few hours. If it's not posted by, let's see, I have a quest right now coming up, but I'll have office hours. If it's not posted by 6:30, then feel free to bombard me with emails and spam and anything you want until it actually posts. You'll find it under files for exam 1. So if it's not by 6:30, then yeah, you can go ahead and do that. Okay, sound good?
Yep.
All right,
Yep.
everyone. Okay, Katarina, I see it. What day is it due? It is due by Tuesday class time. So get it done over the weekends, okay? And